once again. So let me post the attendance link now. I hope I can. Oh, this is a Zoom link. I guess it's a Zoom link. I don't want that. I can make it. Just give me 1 second. I'll post this. Yeah. I'm just wait. I'll be posting now. Can anyone post this Zoom link in the group? So I think I already just posted. Who when this one? There are one more link I'm posting now. Just post this. Some people are having the difficulty. I also posted the Zoom link and attendance link. So just send. Don't post attendance link in the group. You can only post the Zoom link in the group. So attendance link should be here only. Okay. So who will post it and let me tell that because that makes perfect job. Will Sushma Reddy,
Sir.
can you post Zoom link which I posted in the chat box in the group? You are there,
Okay,
right?
sir.
Are you there in the group?
Yes, sir.
Okay.
But admin only can post the
Oh, you're
links
not
or
admin?
no, sir.
Okay. Okay. So I'll make one or two actual admin next. Okay. Right. Anyway, fine. So yeah. So let me. Or are you host? Who changed my host permission, guys? I'm a host, right? And someone changed my host. I am host, right? Say Ainath,
Sir,
you change my host to you?
sir,
Just click my name on the right side. More option is there, and make me host. I gave you co-host, not host. I'm just no, I cannot see that option. I'm a participant. Now I can. I'm a host. Yeah. Okay, guys. Let me share that file. I don't know where I have to check that file now. Right. Okay, I think I can find that. So let me. Yes. But we are almost end of the chapter, which I am. Okay. I think we were in the all coefficient, right? This is over. So I'm going to complete this unit very soon, beta. So almost like we are completing 75% syllabus. So after 2 weeks, I'll be completing this SSP syllabus. Someone is calling. Yeah. Hello. Yeah. I didn't get it. Who? Are you first year? So I'm in the class. Or hello. Hello. Are you first year? I'm in the class, man. Third year. I'm in the class. Call me back later. Right. So Hall effect, we already, I asked someone, Sushma, are you ready to summarize the yesterday? I mean, I asked you to prepare something, right?
Yes, sir.
Can you please?
The BH loop,
Okay, whatever. Oh, BH, what did I ask you?
BH loop.
BH loop, I mean, are you going to tell something about BH loop now? Or you,
Yes, sir.
oh, please.
BH loop, also known as the hysteresis loop,
Oh, very good.
magnetic property of a material.
Okay, very good.
It determines the relationship between the B and H.
Oh, very
B
nice.
is, B is nothing but induced magnetic flux density,
Very good.
and H determines the magnetic force.
Very nice. Then is
Here,
coercivity.
ferromagnetic material that has never been previously magnetized
Okay.
or truly demagnetized.
Okay.
H is increased
Okay.
when
When
the
you,
saturation force
yes, yes. Oh, yeah. When you increase H,
current,
there is a saturation. Then when you remove the field,
it will increases.
yeah. When you remove the field, what happened? Does it come back completely zero? It doesn't, right?
Yes, sir.
So it remains stays. It's a finite magnetic dipole moment or magnetization. What we call that point? Retentivity, right?
Retentivity.
Yeah. Then to make it
Retent.
that zero, what we do? We go for negative field.
Hmm.
So to make it zero, what we call that point? The point where the
Co-
complete course will.
coercivity.
Very good, very good. So to get complete cycle, what we do? What is the importance of that BH loop? What does it give actually? Suppose it's a broader, some material has a broader, some material has a steeper. What is the importance of that? Does it give energy?
It improves magnetic field.
Yeah, I mean, I'm talking about one material. We discussed the soft iron and something else also, right?
Yes,
Steel.
soft iron and steel.
Yeah. So which is the best? Which is a strong actually? Which is a good material, good magnetic material there?
Steel.
Why? Why? What based on the hysteresis loop? Broader? Is it broader?
Hysteresis loop contains that.
Okay. Okay. Yeah, based on the hysteresis itself, we can tell that.
Soft iron is more than the retentivity steel.
Yes. Yes. Yes.
Steel is stronger than the soft iron, sir.
Oh, very good, Sushma. Very good. Thank you, thank you. I mean, if you write those points in the lab, you're gonna get. I mean, just prepare it, and we have that also. All effect also we have lab. You know, 4 Pro method. All this you can prepare it, and it's going to be very easy lab.
Okay,
Very
sir.
good. Okay, right. Thank you, Sushma. I mean, next I'm going to give tomorrow whatever I am talking today. Whatever I'm going, make it admin. I gave the co-host, right? You can add them. I don't want to add. I gave the co-host to someone, right? Yeah. So I can also give Sushma co-host so that she can also. Did I give you co-host? Sushma?
Sir.
Did I give co-host to you?
Yes, sir.
Okay, right. Just add if someone joined. I don't want to waste my time. Yeah. So Hall effects. Tomorrow I'm going to give this work to who is anyone volunteer or do I can give actually. I don't want to. Swapna. Swapna.
Sir,
So tomorrow you are going to discuss this. Whatever I explained today, you just summarize it in
okay,
bullet
sir.
points. Okay.
Okay, sir.
So that you can focus now. So I
Okay.
already discussed what is the Hall effect yesterday, right? So when a piece of metal semiconductor or conductor metal, okay, so what we do actually, Hall effect, we place this any piece of semiconductor or conductor in a magnetic field, in a magnetic field. So then what it produces, the electric field is produced in the conductor and which is mutually perpendicular to the direction of the current flow as well as the, so E, B, I, these three are perpendicular to each other, okay, When a piece of material or conductor or semiconductor placed in a transverse magnetic field, whatever the electric field is produced, which is actually perpendicular to this guy and this guy. Okay, so that is simple, right? So all coefficient, all effect is this simple one. Okay, then how do we, there is a Hall coefficient also there, RH. What is RH? R is actually just simply 1 by Ne. It can tells the charge, type of charge carrier. Suppose material lo semiconductor lo manaku electricity volts valla vastundi, electron valla vastundi. RH can tells that what type of charge carriers in the material can contribute electricity. So RH is a very, very useful constant which can explain the type of charge carriers present in the material. So if it is a p-type semiconductor, holes are the majority charge carrier. If it is an n-type semiconductors, electrons are the majority charge carriers. So as just stated statement, very important, when a piece of material placed in a magnetic field and electric field is produced, and this is all three are mutually perpendicular to each other, and this is called Hall effect. And what is the theory here involving here? Let us consider the p-type semiconductor. P-type semiconductor means you can think about holes are the majority charge carrier. When you place this in a magnetic field as it's shown in the figure, so this is the magnetic field which is in this direction, and you are keeping this is the p-type material, okay, and you are applying, see, you are applying the magnetic field and you have the electric field generation. All three are the perpendicular to each other. This is the B direction and this is the current direction and the other one is electric field direction. All three are the mutually perpendicular to each other. So when a voltage is applied to the sample, when a voltage is applied to the sample, the holes move from, the holes move from contact 2 to 4. They move from top to the 2 to 4. When you apply the voltage to the 3 and 1, there are 4 probes are there, right? When you apply the voltage to the 1 and 2, then volts can move from 2 to 4. So they, because of the electricity, they push volts from 2 to 4. And the drift velocity is given by, drift velocity Vd is given by mu p. It's a volts, p symbol is volt symbol, mobility into electricity. As you know that drift velocity is equal to mu p, electric field V by D, V by L also you can write it. So electric field equation, we already know that V by D or V by L. So I'm writing here. And this is called drift velocity equal to mu P V by L. But here V is the potential, not the velocity. Okay? Not the velocity. So the magnetic field simultaneously exert a force called Lorentz force. So here you have the both fields are there. When you apply the electric field and magnetic field, due to electric field, you have the Q into E. So Q is the electron. And due to magnetic field, QVB. Why? Because, sorry. This is the force. Magnetic field force, electric field force. So here, so let me clarify it. This is the force due to electric field. This is the force due to the magnetic field. So electric field, you don't have the magnetic field term. Q is the electrons. You can also write EE or you can also EVB. So here electrons are moving with a velocity V in a magnetic field B. So what is the magnetic force? QVB or EVB. What is the electric field? What is the electric force? EE. And you just need to remember that. Please add, someone is waiting, guys. I made you co-host because you have to join them. You are just keeping phone and doing your work. That means you're not so see, this is the one, please. And your duty to mute all also whenever you hear sound. Every day I'll change that to, okay, I'm clearing this. Take a screenshot. I'm moving into the Swapna. I think you got this point right, Swapna.
Yes, sir.
So just simple, Nana. When you just need, first point is place the metal or semiconductor piece in a transverse magnetic field, and the electric field is produced inside the conductor. And all these three are the mutually perpendicular to each other. This is called Hall effect. And you can take the sample or semiconductor as a N-type or P-type. When you keep the P-type, you have the drift velocity mu E mu V by L. And we also call Lorentz force. When you have a Lorentz force, when you have the electric field and magnetic field, you have the Lorentz force. So now you can see, Victoria, here the electrical conductivity measurement, we already learned how to measure the electrical resistivity, sheath resistance, right, or resistivity. So electrical conductivity measurement we have learned so far that not sufficient for determining of the number of charge carriers. నాకేం కావాలంటే లోపల ఏ ఛార్జ్ క్యారియర్ ఉన్నాయో ఐ వాంట్ టు నో దిస్ ఎలక్ట్రాన్స్ ఉన్నాయా వోల్ట్స్ ఉన్నాయా సో ఇట్ డజంట్ గివ్ దట్ వి డోంట్ హావ్ పర్ఫెక్ట్ మెజర్మెంట్ mobility charge carriers, what is the mobility of the charges, whether the conduction is due to electrons or holes also I don't know that. So to answer all this stuff we have the RH, Hall coefficient, which could tell all these things, which could tell the mobility, which could tell the type of charge carriers, which could also decide the determination of the number of charges inside the materials. So derivation, beta, Hall effect derivation. Yesterday we learned it already, but here I am giving this is very. I did not give the derivation yesterday. So at equilibrium condition, note down this. At equilibrium condition, the force due to electric field is this. As I mentioned, Fe is equal to Fm. Fe is equal to electric force due to electric field. Magnetic force due to magnetic field. E V B, right? Here we are writing drift velocity. Here we are writing drift velocity. You can cancel it. E. We can cancel it. So E is equal to VdB. We got this one equation. So let us say this is one equation. We also call Lorentz equation. Sometimes competitive exam lo JAM lo adutadu. JAM lo, what is the Lorentz equation? What is the Lorentz force? So whenever you have the electric and magnetic force, we call it as a Lorentz force, which is actually total force, which is electric and plus magnetic. So Lorentz force equation is this one, E plus EVB. This is the Lorentz force, total force. And now the current density equation, we already learned it before. So current density J equal to sigma E, we learned this one, and we also learned NeV. NVV. N is the number of charge carrier, E is the electron charge, V is the drift velocity. Okay. And where N is here, we are talking about the carrier. Suppose if it is holes, we have to keep P. If it is electron, we have to keep as a E subscript, right? And this, let us say 2. So from here, what I'm going to get, so this you can see here. So E is equal to VDB. So you can substitute here beta. E is equal to Swapna. You have to note down perfectly. Tomorrow your job. So B, what is the V? We got it from here. Tell me, Nana. VD equal to J by NE. J by NE. So this equation I got it as a BJ, which is actually this one. Okay? Is it clear? Derivation? Swapna? Sushma? Is it clear?
Yes, sir.
Yes, sir.
So first you
It's
need to
clear,
write this
sir.
equation. Second, current density equation, which we already discussed. Third, actually, you need to get E is equal to VD. From here, you can write it as a E is equal to VDB because E cancel it. And then from here, you can write VD is equal to J by NE and substitute here. And you got this one. Okay. And what I'm writing here, this is, let us say, constant. You can think about this is a constant which we call it as a all coefficient. So in that case, what we are going to get, tell me beta, RH by RH. So no. RH is actually different. RHJB. So RH could be this one, but 1 by NE. So RH is equal to, important formula to remember. RH is equal to 1 by NE. Whatever N is, C is just subscript beta, NE. So this equation we got it from here. We got this one. How we got this one? J is there, B is there, numerator as is there, 1 by denominator, whatever is there, I'm saying that RH. And this is called all coefficient. Very important. In all competitive exam, bit will be there. What is the Hall effect equation? Find out the Hall effect equation. Which of the following equation represent Hall coefficient? What it gives? So let me clear everything you can take now. I think you understand this. From here, I got it as a, what I got it, tell me guys. EH is equals to VDB. And what I got from here? I got it from here.
VD is equal to J by NE.
J by NE, you can write simply. Then substitute here. I got this one. Then from here, I'm writing as a RH BJ, where RH is actually simply 1 by NE. That's it. And this is a powerful equation to discuss the, this is, I'm writing as a 4. So derivation is over, all effect also. Okay? All coefficient derivation is also over. We discussed the experiment yesterday, right? We also see the video, right? All coefficient video, did we see that yesterday?
Yes, sir.
Did you remember it? ఏమైనా గుర్తుందా? ఇదంతా అవసరం లేదు బేట, ఇందాక ముందు ఒకవేళ అది ఎలక్ట్రాన్ అయితేనేమో, సపోజ్ యాజ్ ఐ మెన్షన్ హియర్ RH హోల్ అయితేనేమో యూ కెన్ కీప్ H 1 by N here NE PE you can write. Suppose electrons అయితే 1 by no this is actually NE PE అవుతుంది, ఇక్కడ NE అవుతుంది అంతే. ఒకవేళ హోల్స్ అయితేనేమో you can write PE. If it is electrons, you write it as a 1 by NE. So this is for electrons, this is for holes. Okay, P represent holes, E represent, N represent electrons. Here we are writing like N type means N, P type means P. Okay, N electrons, P holes, and that's it. You don't need to write all this stuff. So I made it easy. Don't worry. I think you're gonna get full marks from this chapter. 25 marks, or I think 20 some one essay, 1 4 marks. Very important for research purpose. What are the applications? Or 4 marks also sometime. All effect can help to tell the whether the charge carriers are positive or negative, or N type or P type. Swapna, remember this point. Hall effect can help to identify the positive or negative charge carriers, or P type or N type. It also helps to calculate the concentration of charge carrier. How many electrons ఉన్నాయి? Electrons ఎన్ని ఉన్నాయి? Holes ఎన్ని ఉన్నాయి కూడా చెప్తుంది. By measuring this carrier concentration, it can also give the charge carrier concentration. Third point, determine the mobility also gives. It also gives the mobility. N is the charge carrier density, electron or hole, mobility, charge carrier density, flux density also, J. It also tells the flux density. It also tells the flux density. It also gives the measurement of electromagnetic waves. Okay. Very good. Is it clear, Swapna, Sushma, anybody, even Samir? Are you there? Shiva?
Yes, sir.
Shiva, are you there? Priyanka?
Yes, sir, I'm there.
Yes. Pavan? Raju, are you there? Raju? What? Nagaraju? People are just watching. Nagaraju, are you there? Nagaraju? Rajesh?
Yes, sir.
Shiva, oh Shiva?
Mallesh,
Yes, sir, I'm there. Yes, sir, I'm there.
Okay, great, great.
Mallesh.
Is ready?
Hello.
Narsimha?
Sir.
Okay, okay. Praveen Gaud?
Vivo 1806.
What is your name?
Mallesh.
Malesh. Sorry. You have to change your name, man. Vivo what? Can't you change your
Okay,
name?
okay, Swami.
Can I change it?
ఇది డైరెక్ట్ వచ్చింది.
లేదు నాన్న.
చేంజ్ చేస్తాం.
నేను చేంజ్ చేస్తున్నా.
యా, ఓకే స్వామి.
మళ్ళీ
చేయండి స్వామి.
GDC అయితేనే కదా?
అవును స్వామి.
ఓకే బేటా. I did change.
వివో
అటెండ్ కానీ హోంవర్క్ ఉంటుంది. హోంవర్క్ మార్కులు ఉంటాయి, అసైన్మెంట్ మార్క్స్ ఉంటాయి. ఫైనల్ ఎగ్జామ్ కి సబ్మిటెడ్. సో
సార్ రామ్దాస్.
ఓకే స్వామి.
చెప్పనా ఏం మాట్లాడాలా మీరు?
సార్ రామ్దాస్ సార్.
Ramdas, I can see Ramdas. Okay. Now the last topic of this unit is band theory of solid. This is also a question will come longer. 2 long answers from here. One is the choice. So band theory of solids. What is the band theory? Is it a band that we do at home, villages? What is the band theory? Most of you have learned from chemistry also, right? If you have a chemistry background. So band theory. So most of you know that. I would understand that. I would definitely, I mean, you have some basic stuff. When I say band theory, you should definitely know this. This is a barrier energy gap. Okay. And here we call it as a valency band. Okay. And here we have the conduction band. Right? So this is the band theory could explain here. And the question is here, based on the energy gap, only we tell the type of material, whether it's a conductor, semiconductor, or insulator. Right? If energy gap is equal to 0 or overlap, those are the conductors. If energy gap is about like 1 to 1 point, so one electron volts or less than less than electron volts, we call it as a semiconductor. If it is Eg is more than 1 electron volts, we call it an insulator. And this is about band theory. That's a very simple way of explaining. Then the question is, how, sir, how do you know this? See, when I apply the, temperature, మీకు ఎక్కువ ఇప్పుడు జ్వరం వచ్చినప్పుడు బయటికి వెళ్ళలేరు కదా. జ్వరం లేనప్పుడు ఏం చేస్తారు? You jump, you go, you play, you do work, everything. Like same thing here. So here, when you don't have when this is more gap, electrons which are fixed here, they don't cross this barrier. They can't jump into the conduction band. Here, total electrons are free. They are mobile charge carriers. Due to this only we have electricity. Here, completely free charge carriers. Here, electrons are free charge. They can move. Here, electrons are bounded. Bounded means they can't move it. ప్రతి మెటీరియల్లో ఎలక్ట్రాన్స్ ఉంటాయి. ఈవెన్ ద ఎనీ మెటీరియల్ నువ్వు తీసుకో, ప్లాస్టిక్ తీసుకున్నా, వుడ్ తీసుకో, ఎనీవేర్ ఆటమ్స్ ఆర్ దేర్. బట్ హియర్ కంప్లీట్లీ బౌండెడ్, నో ఫ్రీ ఎలక్ట్రాన్, నో ఎలక్ట్రిసిటీ. సో ఇన్సులేటర్లో మొత్తం ఇందులోనే ఉంటాయి. సో దే డోంట్ ఈవెన్ క్రాస్ ఇట్, ఈవెన్ ఇఫ్ యూ గివ్ ద ఎనర్జీ, రైట్? సో దిస్ ఇస్ అ కైండ్ ఆఫ్ బ్యాండ్ బేసిక్ స్టఫ్. ఐ వాంట్ టు టెల్ దాట్. Then band theory question, if they ask, you should write it point wise. Explain the band theory of solid using the Crony-Penny model. Crony-Penny model. So then you have to explain this long answer, 15 marks. How do you explain, sir? In order to count for a decreasing resistivity with increasing temperature. What is this? What is saying that he is increasing the temperature beta, baga wait chestunnadu, and he is saying that resistance is along y-axis. He is saying that decreasing resistivity. That's common, right? So if I teach you, what you do, your knowledge will increase it, right? And resistivity means what? When resistance increase, what? Free electrons are more. So conductivity is more, right? Resistance is what? Nothing but a resistance అంటే నువ్వు బ్యారియర్ని తగ్గిస్తున్నావు, అంటే ఈజీగా జంప్ చేస్తే అన్నట్టు వాలెన్సీ బ్యాండ్ నుంచి కండక్షన్ బ్యాండ్లోనికి. సో వెన్ రెసిస్టెన్స్ ఈజ్ లోవర్, you can think about conductivity is current is more, right? So when you increase, you are giving the thermal energy. Increasing temperature means what? We are giving the thermal energy to the material, so that electrons are getting more energy, excite and jump to the conduction band and decrease the resistivity. And what happens? This is for the semiconductors, and this is called band theory is introduced for this purpose. And now the question is, what happened conductor? This is for semiconductor is fine, but conductor is different. It increases, it resistance is. This is a very important graph for competitive exams, geometry. Semiconductors ki resistivity ఏమవుతుంది, conductors ki ఏమవుతుంది? Semiconductors ki ఏమో resistivity decrease అవుతుంది as we increase the temperature. But conductors ki it's quite the opposite. ఎందుకు సార్ అంటే ఆల్రెడీ ఫ్రీ ఎలక్ట్రాన్స్ ఉన్నాయి. బై అప్లయింగ్ టెంపరేచర్ కొలిజన్స్ ఎక్కువ అవుతాయి, దానివల్ల రెసిస్టెన్స్ ఎక్కువ అవుతుంది. అంతేగా బేట, బాగా పరిగెత్తే వారికి 20 మందిని కలిపి పరిగెత్తామంటే వాడు తగ్గుతుంది వాడిని. దట్స్ వాట్. ఓకే, ఈజ్ ఇట్ క్లియర్ స్వప్న?
Yes, sir.
So band theory is based on this, semiconductors, conductors, insulator కి ఎలా ఉంటుందని చెప్పేది band theory is introduced. The essential feature of the band theory is that energy levels for electrons nearly continuous beta. They are not like continuous function. It's like a continuous function, not like a forbidden. అంటే బ్రేక్ కాదు. కంటిన్యూస్ కి డిస్క్రీట్ కి తేడా ఏంటంటే దీనేమో డిస్క్రీట్ అంటారు బేట, ఇదేమో కంటిన్యూస్ లైన్. సో కంటిన్యూస్ అంటే దాని ఎనర్జీ మొత్తం కూడా కంటిన్యూస్ గా ఉంటుంది, నాట్ లైక్ ఎ డిస్క్రీట్ లాగా ఇట్లా ఉండదు. సో వీ కాల్ ఎనర్జీ బ్యాండ్స్ అంటారు బిడ్డ, వీటిని ఏమంటారు? ఎనర్జీ బ్యాండ్స్ అంటారు. విత్ ఏ ఫర్బిడెన్ ఎనర్జీ గ్యాప్స్ బిట్వీన్ ద బ్యాండ్స్. అంటే ఒక ఎనర్జీ వస్తుంది, ఫర్బిడెన్ ఎనర్జీ, అగైన్ ఎనర్జీ బ్యాండ్ వస్తుంది, ఇట్లా. ఈ గ్యాప్లనేమో ఫర్బిడెన్ అంటే కంటిన్యూస్ కానివి ఫర్బిడెన్ అంటారు. సో ఈ పాయింట్స్ కూడా గుర్తుంచుకోవాలి. బ్యాండ్ థియరీకి మనము రెండు ఎందుకు వచ్చిందో చెప్తున్నాం. వై ఇట్స్ ఇంట్రడ్యూస్డ్, వై ఇట్ వాజ్ ఇంట్రడ్యూస్డ్. సో basically to know the resistivity, current, etc., band theory is introduced, and this is definitely continuous electrons. There are energy states for electrons which are continuous over the certain range, we call energy bands. And Crony-Penny model, which is a very famous long answer question, sometimes they are asking. So band theory, he was trying to explain very well an effective way to understand the energy gap in semiconductor is to model the interaction between the electrons and lattice atom. So you have the atoms in the lattice. To understand this, Crony-Penny, the scientist, introduced the model how these electrons, how these atoms and electron is moving here. Atoms are located at lattice sites. How they interact each other. So this potential is atom, like this wave is going like this, and how this wave, electron wave, interact with the lattice sites. That's what he was explaining very well. So Crony-Penny developed the useful one-dimensional model for electron lattice in 1930. Wow, really wonderful, right? That time there was no computer, guys. They're really wonderful. I mean, we're not doing anything now. We have smartphones, we have smart devices. We can search Google for a particular thing. We can discover and get the Nobel Prize, but we're not getting. Do you think we are stupid? No, but we are not focusing much. That's what I'm trying to say. So we have to do a lot. We are not even able to read their books. That's very bad. We're not able to read the Google, like search the Google, whatever interesting stuff. We are Googling very worst stuff. We are chatting in the WhatsApp for nothing. If you can able to spend time to read the textbook, to read the article, to read the nanotechnology, your life, your brain like a nanochip. It acts like a nanochip. And you will be the number one in India. And you will be appreciated by, even if you get 2 lakhs per month, that doesn't give happiness. But when you recognize by someone in India, entire India, you are the top model, definitely money can give the kind of happiness, but the recognition can give the 100% happiness. So we all need to, look for the, get the name for 100% and do hard work. And I hope you enjoy. I hope you will be, number one place in the world. That's what I want my students. Okay. And Crony-Penny is the one who discovered this, lattice interaction between the electrons and atoms. And Crony-Penny, interestingly, he proposed this is the model. Allowed energy, forbidden energy. Allowed energy, forbidden energy. Allowed. See the gaps. You can see that this is the wells, potential wells. So Crony-Penny assumed that electron experiences infinite one-dimensional array of infinite potential wells. And the box infinite wells. Infinite potential wells. Each potential well model attraction to atom and electron potential well in the lattice. So the size of the well must be corresponding to roughly lattice spacing. ఈ size of well ఎంత ఉంటుంది? Lattice space ఎంత అయితే ఉంటుందో, ఆటం ఉంది కదా, ఈ lattice space ఎంత అయితే ఉందో దానికి ఈక్వల్ గా ఉంటుంది బిడ్డ. Okay, and this is his model. How electron interact with the lattice sites, atoms. Crony-Penny is such a great person. He was discussing about the periodic potential interaction, electron interaction with the lattice sites. And he was trying to explain it with a 1D model, 1D potential well model. Okay, very good, sir. We thank you. Then moving into the and he was also trying to assume the wave function. Does anybody know what is wave function? This is a wonder. You should understand that. What is a wave function? This is a quantum wave function, quantum mechanics wave function. We have a mechanics divided into classical mechanics, quantum mechanics. And here we are discussing is quantum mechanics well. This represents a particle, one particle. The particle can be represented as we all know that dual nature of light. Light is a particle as well as the wave, right? It carries the energy from one point to other point. Phonon. Phonon is the one which transfers the light from one point to another point. Proton. Phonon is a thermal energy. Photon. Sorry. There are three things by students. Let me clarify. Phonon, proton. So three terms you have to become an expert. What are these? Photon is a light particle, Li. Phonon is a thermal energy, thermal heat particle. Proton is a basic particle. Proton is a, you know that H11. Proton is a positive charge particle. This is not no charge at all. Phonons and protons are they are completely massless particle. Important bit. Massless, mass undadu vaatiki. Quantum particles, quantized particles, massless particle. They carry the energy, light energy. This is the thermal energy. Okay, so that's the introduction about the wave. This is a quantum wave, so which represent the particle behave, physical feature of particle. So basically, so here we are talking about quantum particle wave function according to the dual nature of light. Quantum de Broglie, what he proposed, any particle, electron also, if it is moving around the nucleus, they treated like a wave pattern, right? So wave is equal to the solution for Crony-Penny model wave equation is, which is the limit that we are talking about. 0 to A is the limit, one dimensional. Okay, wave function is this. This is a plane wave function. This is the reflected wave function. Minus వస్తుందంటే ఇలా వెళ్ళి బ్యాక్ వస్తేనేమో మైనస్ వస్తుంది, ఇది పాజిటివ్. సో psi is equals to AE power IKX is the plane wave. We call it as a plane wave. And plus e power minus IKX, reflected wave. Okay, and K is indicated by its a wave number 2me by h. This is also very important equation, and you should note down. I think did you take the screenshot, students? Yes, did you note down?
Yes, sir.
Right, Nana, very important. And tunneling. What is the tunneling means? Anybody know the meaning of tunneling, Nana? Tunneling ante itla undi Nana. Oka wave ila pass అయిపోతూ ఉంది. ఒక ఇక్కడ పొటెన్షియల్ వెల్ ఉంది బెట్ట. పొటెన్షియల్ అంటే ఇప్పుడు ఒక బాయి ఉంది, ఒక వెల్ ఉంది, దీని పైనంగా మనం జంప్ చేసి పోవడం. చిన్న ఒక గోతి ఉంది నాన్న. What we do, suppose if they do goti, what we do, దీన్ని జంప్ ఇక్కడికి వచ్చి జంప్ చేసి ఇక్కడికి వస్తాం అంటే you are keeping the energy, you are imagining, oh I have energy to jump this. Similarly, electron also have energy to jump it, transfer from here to here. Some of them reflected, few of them like, part of it, transmission through this. That is called tunneling. Tunnel means what do you call it? Tunneling means it's like a part of it goes through the potential. This is the potential well. Part of it comes back, part of it go through the well. So this is the limit beta. The region which we call it as a the electron can tunnel through the well, and the wave function loses its oscillatory wave solution, becomes a exponential potential. So before actually we keep I, there is no here I. First part what we did beta, what we did first part, you can think about, you can see the what we in the previous slide. This is actually AEIKX plus B power minus IKX. But here we didn't keep this wave function is different beta. So when you have this, here it can tunnel. This is called tunneling. Here jump like, it's continuous. That is called, we got it psi1 is equal to A e power ikx plus b e power minus ikx. Then tunneling point we are writing here. So that is psi 2 c e power kx exponential decay. It's exponentially decay avutundi. Psi c e power kx plus d e power minus kx. Okay. And I hope you copied this one also. You have to write down psi 2 k2 again here. And finally, you have to write down this matching the solution about two equation 1 and 2. Crony Penny got this final equation. You have to remember it. I mean, this is actually MSc syllabus beta. They kept to you, but you don't have any basics of quantum mechanics. I'm not going depth because otherwise, it takes like 1 year to teach this quantum mechanics in master level. So when you become a master MSc, definitely I'll teach you that time. But here I cannot teach you this to get how we got this equation. It takes a lot of process. You need to know the quantum mechanics. Okay, but just you can remember here. Don't worry. And this is the final long answer I'm trying to sell. This is a long answer question. And whatever equation we got in previous slide, and keep as this. And the left hand side limited values are plus 1 minus 1. So left hand side is this one, which is the limits of k plus and minus 1. And the plotting this graph, it is observed that there exists restricted shaded region. This is called restricted zone. We call it as a forbidden zones. Forbidden zones. What we call it? Forbidden zone. This is a very important equation. So restricted zones all there. These are the restricted zones. So no, the electron cannot go. Restricted zones. We call it as a forbidden ante povakada. Forbidden ante it's a restricted zones. So what are the forbidden zones? The zones which are not accessible. We call it as a forbidden zones. And this final equation is also very important, Nana. You should able to remember. You have to remember. Any questions, beta? I know you don't say no, sir, right? Did you?
Sir, attendance link పంపరా ఒకసారి మళ్ళీ
Nana?
అటెండెన్స్ లింక్
పంపియాలా?
అవును సార్ చాట్ బాక్స్ లో పంపండి.
I think someone can post it, right? It is there in the chat box, right?
సార్ లేదు రాలేదు సార్ అది.
Nana, Sushma, can you post it again, please? It's there in the chat box.
No, sir.
Why?
నాకు రాలేదు సార్.
అయితే నువ్వు జాయిన్ అయిన లేడీ స్వప్న
Post చేశాను
it,
sir. Yes, sir.
you can post it, right? And select everyone. Malesh. Okay, I'll post it, don't worry.
నాకు వచ్చింది సార్.
Yeah.
Post చేశాను sir just now.
చేసిరా అంతేనా?
అది నాది అయిపోయింది సార్, నాది కూడా వచ్చింది, సర్టిఫికేట్ వచ్చింది.
వచ్చిందా? గుడ్ గుడ్.
వచ్చింది.
సర్టిఫికేట్ ఎంతమందికి వచ్చిందో చూస్తే నాకు ఆ రోజు ల్యాబ్ రోజు అంటే అందరికీ వస్తుంది.
అంటే సార్ ఇది అది ఎట్లా సెండ్ నీకు సెండ్ చేయాలా సార్ సర్టిఫికేట్?
పర్లేదు పర్లేదు, ల్యాబ్కి వస్తారు కదా, ల్యాబ్ అప్పుడు చూస్తారు ఎట్లా రికార్డ్స్ తీసుకురా, చాలా ఉంది ఇంకా మనం స్టార్ట్ చేయాలి. మీ 5 ఎగ్జామ్స్ వస్తాయి, ఇక డేట్ వస్తుంది అనగానే ఇమ్మీడియట్ గా ప్రాక్టికల్ స్టార్ట్ చేయాలి.
ఓకే.
Keep it with you, soft copies. I'll just check it on the, when you come for the, college, whenever you come, you can welcome. I'm at lab only, physics lab లో ఉంటాను. ఎప్పుడు వచ్చినా కూడా ఎప్పుడైనా విజిట్ చేయాలంటే యూ కెన్ కమ్ అండ్ మీట్ us. అసలు మీరు వచ్చి కలిసిపోవచ్చు నాన్న, అందరు ఒకసారి కాకుండా వెనెవర్ యూ టైం ఉన్నప్పుడు వచ్చి కలుసుకోండి.
నేను లాస్ట్ మంత్ కలిసిన సార్.
కలిసినావా నన్ను?
అవును.
ఓకే, కలవండి, వచ్చి కలిసి ఎస్ మై సెల్ఫ్ అని ఇంట్రడ్యూస్ చేసుకొని వచ్చి అసలు ఏమన్నా ల్యాబ్లు రాయాలా, అసైన్మెంట్ అన్ని ఒకసారి డిస్కస్ చేసుకుంటే ఇట్స్ వెరీ, అదర్వైజ్ చాలా టఫ్ అవుతుంది.